Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving deep into a fascinating article, Solving the ABA Problem in Rust with Tagged Pointers. It's all about concurrent programming and lock-free data structures. You know, the really cool stuff.
Right. Lock-free data structures are amazing, but the ABA problem, that's a real headache. So what's the core issue here? Quick summary, please.
The ABA problem sneaks up on you in compare and swap (CAS) operations. Imagine a thread reads a value, A, gets interrupted, and meanwhile another thread changes the value to B, then back to A. The first thread's CAS, only checking for A, thinks everything's fine, but the underlying data might be completely different. Disaster.
Got it. So a sneaky data corruption bug. This article proposes using tagged pointers with versioning, right? How does that work?
Exactly. We tag each pointer with a version number. Every update increments the version. Even if the memory address is reused, the stale version number will make the CAS fail. It's like adding a timestamp to the pointer, ensuring we're working with the most up-to-date version. Clever!
So a simple version counter prevents a complex problem? That's elegant. But, are there any downsides to this approach?
Well, yeah, there are a few. It relies on 128-bit atomics, which isn't universally supported across all platforms. The implementation is also a bit more complex than some higher-level solutions. And, theoretically, there's a tiny chance of version counter overflow, though that's pretty unlikely in practice. A small price to pay for safety, though.
I see. Interesting. So the article also includes tests and benchmarks, right? What did those show?
Absolutely. The tests cover single-threaded and multi-threaded scenarios, ensuring the stack behaves correctly under various conditions. The benchmarks? Well, they're impressive. Single-threaded push/pop is around 186 nanoseconds, while concurrent push/pop is a blazing fast 5 nanoseconds per iteration. That's a huge difference.
Wow, that's a significant performance boost in the concurrent case. The article mentions other solutions too, like epoch-based reclamation and hazard pointers. Are those covered in this series?
Yes, this is part 1 of a 3-part series. The next parts will delve into those alternative approaches. Each has its own strengths and weaknesses, so it's good to explore the options. Stay tuned.
Definitely. This has been a great overview. Thanks for breaking down this complex topic so clearly. It's amazing how a simple version counter can solve such a tricky problem in concurrent programming. Very insightful.
My pleasure. And remember, folks, always be mindful of the ABA problem when working with lock-free data structures. Until next time, this has been Tech Bytes and News. Goodbye.
Bye-bye.